Hello, I'm Roman, and welcome back to a series of videos, Neural Network from Scratch in Golang, where we're using this book called Neural Networks from Scratch in Python, but we writing everything with a Golang. And I created a Discord channel, so I would invite you. Please join so we can talk and discuss things. You'll find link in the in the channel description, in the video description, and in the pinned comment under this and the further videos, so you won't miss it. Currently, there is no one there because I just created it yesterday in the evening, so you could be the first person to join it, and I will be very glad to see you there. So, getting back to the neural networks. In the previous video, I run the model, and we going through the book, we started to build the model on top of the regression. I mean, preparing all of the things for the regression model, and it surprisingly works. I mean, I didn't check, for example, the regularization loss, so maybe there is some issue there, but it looks like it works fine, at least with the Atom optimizer. I didn't check if all of the things can be used because I need to follow the interface and other things. And currently, I'm going next into the book, and there is a, for example, we haven't yet handled for the binary logistics regression. For this, we need to add two things. First, we need to calculate the categorical accuracy. That's what I started. And there is an interesting thing. I think we going to kind of merge, how it's called? Well, accuracy categorical if for both cases, or a case with a binary regression where we have only one, how it's called? For the binary regression model where we have the predictions only as predictions in the target as, how it's called? Two-dimensional array where we have multiple outputs. For example, the first model that we trained in this book was predicting the categories of the data, and we had and this check, if you take a look, it checks if the shape of the y equals to 2. Basically checks if it's a two-dimensional or one-dimensional array, because in case of the binary, it should be shape here 1, but in the Go, I mean, in my implementation, it will be a little bit different. So what I mean, well, first I need to take rows and calls from the target teams. I think actually I will need only columns for this check. Then what I need to do, if it's not binary, if and are and the number of the columns bigger than 1, because in the dense I will always have rows and columns, but for the cases, for example, with the binary categorical, for the binary regression model, I will have some column called column vector, where I will have number of the rows equal to the number of the samples, and number of the columns will be 1. So this is to do for multiple, and here I need to just check value by value, right? Well, not exactly. So the idea that uh, for the two-dimensional and not binary, we need to find, um, we need to convert it actually into one-dimensional because the predictions, well, okay, for the categorical, um, for the model that predicts category, the ground truth, but interesting, why it's, I mean, I'm trying to remember why I had to find the argmax. Why it takes from the compares predictions to the ground truth values, but why we this is the same as the accuracy calculation for the classification, just wrapped into a class and with additional switch parameter. This switch disable one hot to spare label conversion while this class is used with the binary cross entropy model, since this model always required the ground truth values to be a two-dimensional array and they are not one hot encoded. Note that we do not perform any initialization here, but I'm not following. Same, this is the same as the accuracy calculation for the classification. Okay. I should have it somewhere. The accuracy, right? So what I have, this is the regression accuracy. This one is built, right? Do I have the accuracy? Yes. So right now I need to kind of merge this thing. And I have the binary accuracy and this one. So for the target classes, what I did, I made, yeah, this is what kind of confuses me because the model predicted, well, the model output was the two-dimensional array and I had the target classes as a one-dimensional array. And what I had to do, I had to actually find the max index. So basically this argmax, I had to apply it on the predictions, not on the y. And this is why it confuses me, because then I compared it. Then I actually compared it and calculated the accuracy. With the binary accuracy, we assume that they have the same length. So the predictions and the target classes have the same length because predictions could be, well, in case of the binary regression model, there is only one output, what's called one output neuron. So basically there's only one column in the predictions. And in that case, we need to just check. This is the same as I need to understand that the switch disables one hot disables. So, okay, let me think. If it's a binary, we don't do this. We just do this if it's not a binary. If it's not a binary, so it's several categories, so that will be true. And okay, so what it does it converts the situation or where we have y as one hot encoded. Maybe I don't need to actually implement it because I never used it. I mean, it was in the code. I mean, the situation where you define the target categories as not a one-dimensional array, but rather as, so the predictions will have one-dimensional array with a predicted class, and in some cases, target classes can be shown as two-dimensional array where the row represents, well, the length of the row, so the number of the columns is equal to number of the possible categories, and only one, what was this? Only one value in the whole row will be 1 and the rest will be zeros because of the target. Okay, I don't think I actually need this. So I won't do this. And what I need to do, I need to... Okay. First, what I need to do, actually, not here, utils, I want to func compare dims. Just, can I pass the tuple? Like left int right. Can I do this? Expected dash one function declarations. Okay, what if I will do L R L write C as int and it will return bool. And basically what I want to do, I want to compare dimensions and return false if they're not correct. So if the left number of the rows is not equal to right, return false, and then we return if number of the columns is the same. Okay, so then if utils, will it work prediction dims and targets dims? Can I do this? Panic. Incorrect incorrect dimensions. Oh. I mean, can somebody tell me how to deal with this? Oh. Okay. Okay, let's take the reference. Okay, then let's do this. L columns equals to dims, right rows, right calls equals to dims, right? And then we're doing the same. If return false, and then return LC equals to RC, right? Okay. Okay, if not utils, compare dims, predictions, and targets, incorrect dimensions. Okay. Then there is a question, is there is a compare? Not must maybe equal. Compare slices by to new dance use is empty 0. Okay, variables here. Okay, so I assume for compare methods, they should be the same. And what I need to do, I need to convert it into array of balls. Well, two-dimensional array of comparisons. So what I need to do, I need to actually create the result, which will be make plot 64 by the okay, let's take from the predictions dims, as they should be the same, right? So that will be R. Result decorated, not used. Yeah. This can't use. Uh, roles, calls. Okay? Are you feeling better? So then for I equals to range in result, what do? We need to create, and that will be make but number of the calls. Then for in the range of result here, what do? This is, by the way, what is, why it's, no, it's bool, baby. Bool. And there is an interesting question, because it will work for the categories, even that, well, because it's fully, I mean, my implementation is fully implemented on the GoNumDance class, but it uses float 64 under the hood. The problem with this is, what's the problem? By the way, How did I compare the accuracy before? Wait, I have the categorical. I had the loss, had the activation, softmax, loss category, blah, blah, blah. I'm trying to remember at which point I converted probabilities into loss, calculate loss. And what was the loss? Categorical cross entropy. I'm trying to remember at which point I converted probabilities into categories. And I don't remember. Right, so here we have the predictions, we clip them. We have the index, we have the confidences. Okay. So this is a different approach, right? I'm not sure. The thing is that if compare prediction to the ground truth values, so it sounds like it should operate on top of the class, what's called the value that represents, I mean, for the predictions, it should operate on the classes, because in the Y, I will have the ground truth values of the actual categories. So I will write it, I mean, assumption is predictions at this moment has categories, right? Categories value, because why it's important? I don't want to fall into the trap of comparing float values directly, because it usually, even for the round numbers, I mean the without the float part results, it's not good. So to be sure what I want to do, I want to do this. I'm taking the int64. I'm taking the, and I'm kind of truncating what I have in the predictions. Yes. And same I'm doing for the target. I'm not sure that's the correct thing, but this is why it's, you know, a big assumption. This is important. Okay, maybe. Okay, let's do. It's still a big if for me, because I mean, here for the, and it's actually, if you think about this, it's the same for the binary, right? I will have to do this conversion somewhere, because for the, I mean, if you take a look on the accuracy on the binary, there is this code that goes through predictions, and the prediction is the column vector, and it checks if the probability is bigger than 50%, then it's, you know, one class. If it's not, then it's another class. So I assume that we should do it at some point based on the type, what to call, based on the type of the category model. If it's the model with one output neuron, then it's a binary, then we should write something like this. If it's not, then we should write something like this and pass it to the Yeah. Oh, maybe, yeah. So let's see. So right now, the next thing that we need to add is ability to validate the model using validation data. The validation requires only forward pass calculation. Validation only requires a forward pass and calculation of the loss. This data loss will modify the calculate method of the loss class to get it calculate the validation as well. We'll modify calculate method of the loss function to let it calculate the validation loss as well. Where? This if just a data loss returned. Calculate. Wait. Calculate loss. Okay, so we have the sample loss. We have, yeah, we calculate the mean value and that's it. We have added a new parameter and condition to return just the data loss as organization loss is not being used in this case. That's not my case because I trigger the regularization loss from the loss object directly, right? Because calculate loss, right? Yeah, I need to fix it. Yes, I trigger it from the object itself. Yes. So, loss. Um, Wait. Um, Train, not this one. Mhm. I need to configure the node tree a little bit better. Sometimes I close the node tree itself and it's okay. I have this. Um, So yeah, this is why I don't need to pass any parameter here. We have Tyrant will pass predictions and target the same way as with the training data. We will not. Yes, I have the loss function, I have the output, and yeah. Will not return regression loss by default, which means we need to update code to this. It's not my case. Then we can add the validation code to the training methods in the model class. We added validation data parameter to the function which takes a tuple. Oh, okay. Which takes a tuple of the validation data sample and targets the if statement to check if the validation data is present, and if it is, the code is performed a forward path over this data, calculate loss and accuracy in the same way during. Okay. Um, mm. If there is the validation data, we okay. Train epochs. I'm thinking, can I pass nil as the validation? And maybe I'm thinking maybe I need to create another struct and, type not data will be x and y, and then will be math dance, right? Struct. Why do I want to do this? This is why. So I have the training data, right? And then what I do, x and y equals to training data x training data y. Does it make sense? And validation data as data. And then can I check? I think it's we need to do it after the epochs, right? Wait, this because we do it in the end. So if validation nil, is it a valid check? Empty branch. Okay. So I have the run, no models, not this one. Models. What I'm checking? I'm changing the. We'll have the regression that is. Yes. So what I want to do, model train. What I have the model date model dot data and x and y. Then I have 10k every 100 and here nil. Model data is not a type. Come on. Of course it's a type. Okay. Okay, data. Model data. And yes. No. No, yes. No, yes. No, 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 no. Model. So, right? Model data. What do you mean it's not model? Mm. Okay. Probably there is a collection of the names. Okay. Just see. No. 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 Yes. No. No. Yes. 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 No. No. But is it better? Struct literal uses unkeyed. Monodata struct literal uses unkeyed fields. So you want me to do this? Now you're satisfied? Okay. So if we have validation data, which means it's okay to query it. Well equals to validation data x, validation y, right? Output, we need to do the forward pass. Okay, validation output equals to, well, forward x val, right? And then we need to calculate the loss. Validation loss will be loss calculate loss. We're taking the loss function, we're taking the predictions, which is output, validation output, and we have the target, which is y val. Yeah. So we have the validation loss, get predictions, and calculate the accuracy. Predictions and the accuracy. So what do we do to do this? We have the predictions and the accuracy, right? But instead it will be validation predictions, right? And here validation accuracy. Instead of the output, it should take what it should take, you might ask. It will take validation output. And same here. Oh, a validation predictions. Validation declared and used. Okay. And we can print a summary where I have, but it will be shorter because I don't need epochs, right? So we have the loss, which will be the validation loss. We don't need this. We have the accuracy, which will be the validation accuracy. That's it. And what do we do? Validation. Where? Yeah. The full train methods. Okay, so we have the initialization of the accuracy. We have the loop through the epochs. We calculate the output from the forward methods from the whole model that goes through all of the layers. Then we calculate the data loss, aggregation loss, and the total loss. Then we calculate the predictions and the accuracy. Well, we calculate the accuracy. In order to do this, we need to calculate the predictions for the accuracy, and then we don't need to pass the trainable layers anymore. At which point it was removed. And where we pass it, Mm, do I need this still? Or loss function holds references to actual data. Okay, then I have the backwards call. I call the optimizer. Yeah, I need to downcast. Well, in the layers I store everything that is. By the way, but I need I have them right in the model. No. Yes, I have the okay. Okay, yeah. Then I'm downcasting the interface to a concrete class, well, concrete struct in this case, and taking all of the layers, ignoring activation functions. And when I have the layer, I taken it. So this is from the trainable layers, but I just do it with the downcast. And then we call the post update params. Then we have this. Yes, and then if there is a validation data, then we take in the validation data. Validation output. So it's calculating the output. So we call in the forward pass, we calculating the loss, we calculating the accuracy, and we printing all this. Now we can create the test data and test binary logistics regression model with the following code. And I think I commented it fully because I had many compilation errors. And let me check. And what I will do, I will start from this in the next video because I expect problems with the way that I pass data. I need to fix the way that they declared some of the interfaces. So that should be the next thing. I postpone it more and more. I think, yeah. So these two things, um, it between remove classifier package, move into lost, fix models. Well, fix models is kind of in progress. That's how I will start the next video tomorrow. Again, reminding you about the Discord server. Don't forget to check it. Don't forget to join it. And I will try to make it an interesting place to discuss ideas and all the things about coding, software engineering, etc. Thank you for watching, and I see you tomorrow. Bye bye.